Hi there guys, welcome to Learn Extra. In today's grade 11 lesson we're going to be having a look at functions, transformations and financial mathematics. We're going to make sure that the concepts that you've learned so far have been properly assimilated and that you guys are ready for that exam. Now starting off with functions, I just quickly want to talk to you guys about things that are important for us to know. Quick little bit of revision. First off, let's start with a parabola. All right, so our parabola has got the general equation y is equal to a x minus p squared plus q. Now, it's important that you guys remember we don't have to use a, p, and q, but based on the positions of the a, the p, and the q, we know what they are going to do to our graph. Now, let's first look at a. A controls the steepness of a graph. So, a graph with a bigger a value will be steeper than a graph with a smaller a value. So, that is what a does. It controls our steepness. Then we have a look at P, and what does the P do? The P moves the graph left or right. So we refer to the left or right movement as a horizontal translation. A plus in the P will move the graph to the left, and a minus will move the graph to the right. It's very important that you guys remember, because we're dealing with functions, it is different from when we're just translating a single point. Right. Then what does Q do? Well, what Q does is Q controls our vertical translation. So Q moves the graph up and down. A positive value for Q will move the graph up. A negative value for Q will move the graph down. Another important thing to remember is if our A value is positive, our graph will be a happy, smiley parabola. And if the A value is negative, we will have a sad parabola like that. Right, so those are the important things to remember for a parabola. Remember, guys, for the x-intercept, we make y0. For the y-intercept, we make x0. And these things are not just particular to parabolas. They go for all functions. Now, let's have a look at our second graph, and that is our friend, the hyperbola. So the hyperbola has got a general equation. Y is equal to a over x minus p plus q. Right, now remember, the hyperbola is the graph that appears in two bits, either in the first or the third quadrant, or the second and the fourth quadrant. Again, the value for a controls the steepness of our graph, and if a is positive, our graph will be in the first and in the third quadrant. However, if a is negative, our graph will be primarily in the second and in the fourth quadrant. P, just like the parabola, is what moves our graph to the left and to the right. So a positive value for P means it moves to the left, and a negative value for P means it moves to the right. Again, just like for the parabola, Q moves the graph up and down. Now, with the hyperbola, we've got some interesting features that we don't have with the parabola, and those are our asymptotes. Now, if our equation is in the standard form that it is over here, our first asymptote will be at x equal to p. And that, of course, is a vertical asymptote. So we will have a vertical asymptote at x equal to p, and we'll have a horizontal asymptote at y equal to q. Right. It's very, very important that you guys remember that you don't have to learn the parabola as one thing, the hyperbola as another thing. Rather see functions as a group and remember that the same effects apply to all of them. Finally, well, I'm not going to look at the straight line graph right now, so finally for now, we have a look at the exponential function. Y is equal to a, b to the power x plus q. Again, remember that q moves the graph up and down. B controls this, a rather, controls the steepness of the graph. And if I insert a p-value over here at the x, again, a negative p will move the graph to the right, and a positive p will move the graph to the left. Right, so I think with that little bit of revision under the belt, we're ready to tackle our first question. The first question says, given f of x equal to 2 over x plus 1. The first thing that they ask us is to write down the value of the asymptotes. Now, I like to deal with my graph in the standard form at all times. So I'm going to rewrite this as 2 over x minus 1. Right. Fair enough, so that you guys can see that that is exactly the same thing. And I'm putting a plus 0 in for the value of q, just to remind me that this graph is not being translated up or down. So, as I said to you guys just now, if we want the equation of the vertical asymptote, that's the one going down, it is always x is equal to p. But remember, for that your graph must be in standard form, and that's why I put x minus 1. So I can quite comfortably say that my vertical asymptote will be at x equal to negative 1. Right. Now there's always two asymptotes with our hyperbola. They say, give the equations of the asymptotes. Remember what I said just now. Your horizontal asymptote will be at y equal to q. And remember, q is that part of the function that translates it up or down. Now in this case, our function has not been translated up or down. Q is 0, so I can say y is equal to 0 is the equation of my horizontal asymptote, right? So very important, guys, if you just remember to put your graph into standard form, you really don't have to struggle too much. Just a point quickly, why is x equal to minus 1 a vertical asymptote? Guys, because if I make x equal to negative 1, what will I be doing? I will have 2 divided by 0, and of course that is undefined, and that is why my graph cannot be drawn in that region. Right, so the first question for 2 marks should be quick and easy if you know your theory quite well. Let's have a look at the next question. The next question again deals with our same graph, and it now says to us, sketch the graph of f indicating the coordinates of the y-intercepts as well as the asymptotes. Right. Now we already know the equations of the asymptotes. We can write them down again quickly. X is equal to minus 1 and y is equal to 0. Now before we can sketch the graph, we need to calculate the y-intercepts. There aren't any x-intercepts because the x-axis is actually an asymptote. Now, very important, once again, this is not something that's particular to our hyperbola. This is true for all functions. If you want the y-intercept, what do? You make x equal to 0, and that's exactly what I'm going to do. Really not too difficult. I'm dealing with f of x equal to 2 over x plus 1. So I'm now going to just change the f of x into y, and I'm going to say y is equal to 2 over 0 plus 1, and of course that means that my y-intercept is at 2. Right, so that's the only y-intercept that I have for this graph. Again, guys, you could have x-intercepts. In fact, you will have x-intercepts the moment you have a q value, because the q value moves the graph up or down. Then the x-axis is no longer an asymptote, and your graph will intersect the x-axis. In that case, to calculate the x-intercepts, what you will do is you will make y equal to 0 and solve your equation. Right, I think we've now got most of the information that we need, and we can now get on with the business of sketching our curve. Guys, you do not have to take hours and hours about sketching your curve. It doesn't have to be an absolute artwork, but certain things are really, really important, and I call them the critical points on your graph. The critical points on your graph are places where there are asymptotes, where there are turning points in the case of parabolas, where we intersect the x-axis and where we intersect the y-axis. Right, so very important. I'm putting my arrows onto my axes, and it's very important that you label your axes. You might not necessarily get marks deducted for not labeling your axes, but it always creates a good impression if you leave nothing to chance. Okay, now once I've got my system of axes going, I'm going to highlight my asymptotes. Now, the first asymptote isn't really that much of a problem, because the first asymptote is actually on the x-axis, but I'm going to highlight it nonetheless, just so that I remember that it's there. So on the x-axis, I've put a little green line, and also over here at x equal to -1, I'm going to put a green line. And it should preferably be a dotted line to show that your graph is not defined in that region. Right, so back to my favorite color pen. Over there at 2 on the y-axis, I'm going to show my y-intercept, and I can get on with the business of drawing the graph like that. Is absolutely fine, and I'm going to reflect it in the third quadrant over here. Guys, it's very important that we understand the effects of our A, our P, and our Q, right? But sometimes in an exam situation, you might be feeling a little bit unsure. And in that case, you can use your Casio calculator to help you just see whether your points or whether your graph is more or less fine. So I'm going to bring up the calculator, right? So we'll clear the calculator, and we'll go to mode, and I will go to table. What I'm going to do now is I'm going to enter the equation of my graph into this calculator over here. So I'm going to start with a fraction. I'm going to put the 2 at the top. Then I'm going to scroll to the bottom. Now I need to put the x in, and it's x plus 1. So what you do is you go alpha, and then you press the X button over there. The X is actually one of our brackets. And then I'm going to put plus 1, and I'm going to enter this by pressing equals. Then your calculator is going to ask you, where do you want it to start? So let's start our graph at -4, and we'll enter that. And where do we want it to end? Well, the calculator says 5, so why not? That's fine. We'll enter that. And then it asks for steps. So what we're going to do is we're going to go in steps of 1. That's absolutely fine. And equal. And then this is really quite interesting, because you can look at the values on your table and you can see whether that actually corresponds to your graph. Now, does it look probable that at x equal to -4, y will be minus 0,666. Yes, I think that's absolutely fine. Then here's a lovely point. At x equal to minus 3, y is equal to minus 1. So we might want to actually put that onto our graph. And let's keep on scrolling down. And let's see what happens at x equal to minus 1. At x equal to minus 1, I have an error message, and that means that my graph is not defined at x equal to minus 1. It doesn't mean that I made an error. It means that my asymptote is in exactly the right position. Right, so you might just want to do this afterwards just to make sure that your graph makes sense, and that can also help you put some extra points onto your graph. So from what I saw over there, I saw that x is 1, y is 1 is a point in this first part of the graph, and also x is negative 2, y is negative 2 is also on the graph. That just creates a good impression that despite the critical points, you've also got some other points to bring to the mix. Right, so without too much trouble, we've managed to construct this graph. Now, very typically, after we were asked to sketch a graph, we're going to be asked to do something with our graph. So let's have a look at our next question. The next question says, write down the equation of the graph formed if this graph f is shifted 3 units right and 2 units upwards. Now, this is where it is very, very important that you understand what is it that controls the left and right shift, and what is it that controls the up and down shift. Okay, so left and right shift is controlled over here. Okay, if your graph is moving 3 units to the right, whatever I have here before, I will subtract 3 from it. I just want to remind you again that it's opposite from what I do when I've got a point. If you're moving a point right, you do it by adding. If you're moving a point left, you do it by subtracting. However, this is a function. So a point right is minus, and a point to the left, or a graph to the left rather, is plus. Right, so that's the first thing. Then remember how I told you guys that it's the value of the Q that shifts the graph up and down, and they specifically say 2 units upwards, so that means plus 2 over there. Now, obviously, your question will not be finished until you've simplified this properly. So I'm going to say the new f of x, or the new graph, is equal to 2 over x minus 2 plus 2. Now, we are not really asked at this point. Let me just fix that too so that you can see. We're not asked anything more about this graph at this point, but let's just quickly talk about what I told you guys earlier. If I now had to sketch this graph, my first asymptote, which is my vertical asymptote, will be at x equal to p. So this graph has got an asymptote at x equal to 2. It's also got an asymptote at y equal to 2. Why? Because 2 is the value of p, but 2 is also the value of q. Right, guys, I'm often very distressed when I see that people just don't like graphs. They don't like these parabolas and hyperbolas. But really, if you take the time to get to grips with the basics, you should be able to fly through any graph question. Now, we've got another graph question for you guys. In fact, sorry guys, there's another question on this graph. Sorry. Final question says, determine graphically the values of x for which f, my graph, is bigger than or equal to 1. Now, the fact that we say graphically means you don't need to do a calculation. You actually have to go back and look at your graph and decide from there when this will be the case. So the question says, where is the graph greater than or equal to 1? Now, what I'm going to do is I'm just going to draw a line through here at 1. Now, can you guys see what the question is really asking me is, where is my graph above my new orange line? Now, my graph is above my new orange line in this region over here. From x equal to 1, from and including x equal to 1, up to the asymptote, but not including the asymptote, because remember, your graph is not defined at the asymptote. So this is going to be x greater than -1, not included because the graph is not defined at the asymptote, but less than or equal to 1. Right, lovely question on a hyperbola. Absolutely no reason why you can't absolutely get full marks for that guy. Right, now the other two graphs that I discussed with you guys earlier on, the other two functions, were the parabola and the exponential graph. And the question number 2 deals with those two graphs exactly. Now, before I even look at what they're asking me to do, I'm going to look at the equations and just try and form a bit of a mental picture. It says given f of x is equal to 2. Now, remember, 2 is then the value of a. Couple of things that I can see from that. The fact that a is positive means that my graph will be a smiley parabola. It will have a minimum turning point. Okay. Then, remember the standard form is x minus p. Now, the fact that we have got x minus 1 means that my graph has moved to the right by 1 unit. So what I mean with to the right is if you think of the graph that's around the y-axis, it's now moved that way. Okay, no problem. And then this -8 is actually our q. And remember that q moves the graph up or down. And the graph has moved down by 8 units from the standard position because it is a -8. Right. Now, our exponential graph actually isn't too bad. H of x equal to 4 to the power x. You could write this as 2 to the power 2x if you wanted. And there's no shifting going on with this graph. It hasn't shifted upwards, it hasn't shifted left or right, so not too much of a problem. Right. So the first question says, sketch the graphs of h and f on the diagram sheet provided, indicating all intercepts with the axes and any turning points. Right. We're going to start by sketching the parabola. Once we've got the parabola sorted, we'll have a look at our exponential graph. Now, what is important for us to remember with our parabola? Well, we need to have the turning point. We need to have our x-intercepts, and we need to have our y-intercepts. Now, once again, guys, it doesn't change from one parabola to the next. Once you guys have mastered these skills, it will be with you forever, and you will never have to fear a parabola again. Right, so my parabola is in the standard form. I'm just writing it down again. Remember, the standard form for a parabola is y is equal to a x minus p squared plus q. And once your parabola is in the standard form, where the square is completed, your turning point is actually not a lot of work at all. P and Q are the x and the y values of the turning point respectively. So I can immediately say that my parabola turns at 1 and at -8. Right, so 1 and -8 is the turning point of my parabola. Now, let's get on with the business of the x-intercepts. Remember, for any function, for the x-intercepts, we make y equal to 0. So I'm going to say 2x minus 1 squared minus 8 is equal to 0. And now I am just going to solve this equation. So if you want to, do it in steps rather. Multiplying out the brackets gives me x squared minus 2x plus 1 minus 8. And distributing the 2 in 2x squared minus 4x. I'm going to get plus 2, but with the -8, it's going to be -6 equal to 0. So I can make my life a bit simpler by dividing through by 2. X squared minus 2x minus 3 is equal to 0. And let's solve this equation, not much to it. X minus 3, x plus 1 equal to 0. So I've got x-intercepts at x equal to 3 and at x equal to negative 1. A good way to check yourself, of course, is that the x value of the turning point has to be exactly halfway between your two x-intercepts. And in this case it is, so no problem there. Let's move on to the y-intercept then. For the y-intercept, we're going to make x equal to 0. So we're going to say y equals 2, 0 minus 1 squared minus 8. And we solve this to find that y is equal to negative 6. So I am ready to sketch this graph. Remember what I told you guys before. It's really important that you have a neat and a legible graph. You do not need to spend hours on it. But please do use a ruler for your axes. It just creates a better impression. So there's my y-axis and my x-axis. And now we need to put on all of our important points. So we know that the graph turns at 1 and negative 8. Let me just move it up ever so slightly. So I'm going to put 1 and negative 8. And please, guys, label the turning points. Don't expect the examiner to try and sit and figure out where they are. Then also, my y-intercept is at negative 6. And then I have x-intercept at minus 1 and at 3, respectively. And really now I am just connecting the dots. Remember, guys, you cannot use a ruler when you're connecting the dots. It has to be smooth and curved. You can't just draw a straight line down. So this is not brilliant, but it's okay. I think we will get our marks for that one. Right, so let's have a look at our exponential function. I'm going to start by just writing down the general equation. Y is equal to a times b to the power x plus q. Now, our exponential function also has a horizontal asymptote, and the horizontal asymptote has the value of q. So, in this case, because I'm dealing with y is equal to 4 to the power x, and there is no q moving the graph up or down, I can say that the x-axis is going to be my asymptote. So therefore, guys, there will be no x-intercepts, right? So once again, I'm telling you guys, the q moves the graph up and down, and your horizontal asymptote is determined by the value of q. The fact that this is plus 0 means that the x-axis is an asymptote, so therefore my curve will not intersect the x-axis. But we do need to get our y-intercepts, and for the y-intercept, of course, you make x equal to 0. So I'm going to say y is equal to 4 to the power 0. Now, by now, guys, you should know that anything to the power 0 is equal to 1. So that means that the y-intercept of my exponential curve will be at 1. Once again, what you can quite easily do, because it'll definitely give you confidence and it'll give you some extra points, points on the graph, not points in the paper, you can use your calculator. We will do that again just now. So I'm going to put the y-intercept on here, over there. Now, before I connect my curve, because I now only have 1 point, I'm going to take out my calculator and I'm going to say, why not? Let's get back to our table function. So I'm going to say f of x is equal to 4 to the power alpha x, right? And I'm going to enter that equation. It says to start at minus 4, why not? That's fine. End at 5, that's fine. Steps 1, that's absolutely fine. So it's not that important to us, the values that are not whole numbers, but we can have a look here and we can see that where x is equal to -1, y is a quarter. Where x is equal to 0, y is 1, which means that I've worked correctly. And let's just get one other point on the graph. Where x is equal to 1, of course, y is equal to 4. So I'm going to put that one on. Maybe just line it up nicely with your turning point over here. Sorry, just do a dotted line. It's not the best dotted line in the world. Let's try that again. So where x is 1, y is 4, I'm going to put that onto my exponential curve, 1 and 4, and I'm then going to connect my graphs like that. Okay, guys, so there we have it. We've sketched the two graphs with quite a bit of success. Let's have a look at what questions they now ask us about these graphs, because that is where things get quite interesting. Right, so the first thing again has to do with shifts, with moving the graphs up and down and left and right, and you guys should be quite fine with that by now. The graph of f, so that is our parabola, is shifted 2 units to the left. Okay, the graph of f is shifted 2 units to the left. So now we must remember, what do we do for to the left? We are actually going to add 2. So I'm going to say f of x is equal to 2, and you add it where your x's are, x minus 1 plus 2 squared. And now they ask, write down the equation of the new graph. So presumably the q value hasn't changed at all, so we'll keep that the same. And all you need to do is fix this up, simplify. The equation of the new graph is 2x plus 1 squared minus 8. Nothing to it. Remember, to the left we add, to the right we subtract. Up we add, down we subtract. Let's have a look at the next question. Okay, so still dealing with our parabola and our exponential graph, we are now asked to show algebraically that h of x plus a half is the same thing as 2 times h of x. Now, many people might have a problem actually just understanding what the question means. If I say to you h of 2, what you will do is everywhere where there's an x, you will replace the x with a 2. If I say to you h of flower, everywhere where there's an x, you will replace the x with a flower. Now, in this case, we are asked to deal with h of x plus a half, which means everywhere where there's an x in my exponential graph, I'm going to replace it with x plus a half. And then I'm just going to play around with it and hope that I prove what they ask me to prove. So that's the most important part, is just knowing where to start. So h of x plus a half. Now remember, our exponential graph was 4 to the power x, but now all of the x's are replaced with x plus a half, so I'm going to do that, x plus a half. Right. What I now need to do with this x plus a half is I need to play around with it and show that it represents twice my other curve. So let me see, what can I do next? Well, I could do this. I could say 4 to the x times 4 to the power a half. Now, remembering that my original graph was 4 to the power x, I don't really want to play around with that too much. But what is 4 to the power a half? Well, anything to the power a half is the same as a square root. And of course, the square root of 4 is 2. But another way that you can look at it is you can say 4 to the x times 2 to the power 2 instead of 4, everything to the power a half. And then the 2 and the half cancel out, so I end up with 2 times my original graph, which is 2 times h of x and I have managed to prove what they asked me. Right, guys, that concludes the functions section of today's lesson. Very, very important. You cannot afford to say, oh, I can't do functions. You're going to have to forego a lot of marks in your matric exam, and it's just not worth it. It is so easy. Just keep on practicing and remember to stick to your rules. Right, we're going to carry on, and now we're going to have a look at transformations. Now, there's a couple of things that we need to remember for transformations. Remember reflection in the x-axis, reflection in the y-axis, reflection in the line y is equal to x, reflection in the line y is equal to negative x, rotation through 90 degrees, rotation through 180 degrees. Now, it's not always easy to remember those rules, but what I do, if I'm having a hard time remembering what I need to do, is, guys, just draw a picture. It's the easiest thing in the world. So let's say, for instance, you are very nervous in an exam and you are asked something to do with reflection in the y-axis. Draw yourself a point. Draw yourself a point, let's say 2, 3. Now, if this point is reflected in the y-axis, it means that if I fold my paper on the y-axis, let's say that's a very wet dot of ink, I fold on the y-axis, where will that ink be pressed off? Well, it will still be the same height above the x-axis, so the y-coordinate will still be 3. But what happens to the x-coordinate? The x-coordinate changes sign. So if it was positive, it will turn into negative. If it's negative, it will turn into positive. Similarly, if I reflect in the x-axis, the x position remains unchanged, but the sign of the y changes. So again, now we're thinking of our x-axis as where we fold the paper, and that's a wet dot of ink, and it's going to make a little mark over there. Remember, when we reflect in the line y is equal to x, the x and the y values switch around, and so on. The good thing about these questions on transformations is that they are very visual. There's always pictures involved, which is great, and the pictures usually help us solve the problem quite easily. So let's have a look at this first question. The question says the diagram below shows quadrilateral, that's a four-sided figure, PQRS, its transformations A, B, C, D, and scrolling down, I've got another transformation W, X, Y, Z. Right. So before we even look at the question, we can say, well, what can I see going on there? Well, perhaps these two are reflections of each other in the y-axis. Not too bad. Okay, first question. State the general rule for the coordinate of any point representing the transformation of quadrilateral PQRS to quadrilateral ABCD. Now, as I said to you guys just now, what happened here? PQRS was reflected in the y-axis. Now, if they say describe the transformation in words, then you will say quadrilateral PQRS was reflected in the y-axis to yield ABCD. However, they want the general rule from us. Now, guys, I would, if I were you, to be on the safe side, write down the general rule and describe it. Then you'll never go wrong. So what we're going to say is from PQRS, if we call that x and y, the transformation is negative x, same y. Okay, negative x, same y. And you can see that is absolutely true, because let's have a look at the point P over there. What happens from P to A? Well, the x becomes negative and the y value remains absolutely unchanged. So nothing too hectic about that one. That is all that we're looking for in the answer. But as I said, if you're not sure, write down the rule and also just describe it in a sentence. Nobody will ever take marks off for giving too much information. Right, so we are back to these same quadrilaterals, and now we are asked more things. Now they say describe, which means they now want us to use words. Describe two possible transformations of quadrilateral PQRS to WXYZ. So that's from this one to that one. So we need to think of two ways, two different things that we could do to make this one turn into this position. Right. Now the first thing that should be relatively obvious to you is that I could have done a rotation of 180 degrees through the origin. A rotation of 180 degrees through the origin makes absolute sense to me, and you can also confirm it by having a look at that point P's position over here and the point W's position over there. So X and Y has turned into negative X and negative Y, and that is indicative of 180 degrees rotation through the origin. The other possible, and here we will write a sentence because the question very specifically asks us to describe. The other possible thing that we could have done is we could have taken PQRS and reflected it in the y-axis to give us ABCD, and then reflected it in the x-axis again to give us WXYZ. Nobody said it had to be one step, so those will be your two possibilities. Either a rotation through 180 degrees or a two-step process, reflect PQRS in the y-axis and then reflect PQRS in the x-axis. Right, so nothing too difficult about that so far, I don't think. Still with our quadrilaterals, now onto the third question. Write down the coordinates of the reflection of point D in the line y is equal to x. So let's find point D. Now that's interesting because at this point we don't know what point D is. But what we do know is we know that the quadrilateral ABCD is obtained by reflecting PQRS in the y-axis. So it should be pretty obvious that D is x is equal to -2 and y is equal to 2. Now that we have the coordinates of D, which are -2 and 2, we have to now reflect D in the line y is equal to x. Now the rule for reflection in the line y is equal to x is a very simple one, guys. All that happens is the x and the y coordinates switch around. So if my x and y coordinates were -2 and 2 respectively to start with, once I've reflected in the line y is equal to x, the reflection, let's call it d dash, will be 2 and -2, and all that happens is that the coordinates switch around. So this first question on transformation is not too difficult at all, and just testing whether we know our rules. But as I said, guys, the nice thing about transformations is it's so visual. You can see what's going on. You don't have to wonder whether you're working correctly or not. Right, let's have a look at our next question. Question 4 says, A, B, C, and D are coordinates of the vertices of a quadrilateral. Right, so there we have them nicely drawn for us. Nothing too much to it. Let's start with the first question. ABCD has to be enlarged through the origin by a factor of 2 units. Now guys, remember, enlargement is not a rigid transformation. What do I mean by that? All of our other transformations, we're just reflecting and we're taking the same shape and putting it in a different position. Enlargement, however, we're changing the area of our figure, although the basic properties still remain the same. Now the question says, draw this enlargement on the diagram above and indicate the vertices A prime, B prime, C prime, D prime. Right, now well, before we can draw them, we need to know what to do. And really, guys, very, very simple. If we're enlarging by a factor of 2, both the x and the y value of our original coordinate is multiplied by 2. If we're enlarging by a factor of 5, both the x and the y value of our original coordinate is multiplied by 5. So if we have to now get the new position of A, it will turn into, let's just write it down on the side here before we draw it, 2 and 6, and I obtain that by just multiplying. So now I'm going to go, so that's 2, 4, 5, 6, so over there. Call it A prime, and I've already named the coordinate over there on the side, so I don't have to do that again. Now I'm going to do exactly the same thing for B. If I take 3 and I multiply it by 2, then it changes to 6, and 2 multiplied by 2 to 4. So B prime is going to be x is 6, y is equal to 4, so 3, 4, 5, 6, and y is equal to 4 over there. Call it B prime. Moving on to C, C will become 2 times 2, which is now 4, and negative 1 times 2, which is negative 2. Again, I'm going to put it on my graph, and that will be over here, C prime. I'm not going to put the coordinate in because I've already written it on the side. And finally, we're going to deal with D. Same rule, very, very easy. D will become x is 2, y is 0. X is 2, y is 0, and that is D prime. And now I'm going to connect these lines to reveal my enlarged version. Guys, it's very important, of course, that the shape still has to look the same. It just has to look like a grown-up version of the other one. Right, now that we've done the first question, the second question is actually really very easy. They ask us to write down the coordinates of A prime and C prime. Now, we already wrote them down just now. A prime, of course, was 2 and 6. That was our enlarged coordinate. And C prime was 4 and negative 2. So nothing to it. You had to write them down anyway while you were doing the enlargement. So nothing much to that question at all. Right, so let's have a look at something a little bit meatier. Now, they say to us that the area of our original quadrilateral is x square units. And now they want us to determine the area of the enlarged quadrilateral in terms of x. Now, guys, this is very important. What we need to remember is that area is, in fact, length times breadth. Now, I have taken each of the sides of this quadrilateral and I've made it twice as long by enlarging it by a factor of 2. However, it's going to have a different effect on the area. And let me explain this by just doing a little separate lesson. If you guys look at a square with sides 1, 1, 1, the area of this square is length times breadth, which will be 1 times 1, which is 1, let's call it centimeters squared, if that was a centimeter. Right. Now, I enlarge this square. I double the length of each side, 2 centimeters, 2 centimeters, 2 centimeters, and 2 centimeters. And what happens to the area? The area is now 2 times 2, so the area is 4. So what happens if I enlarge by a factor of 2? The area is, in fact, 4 times as big. Or if I enlarge by a factor of 3, what will happen now? The area will be 9 times as big. So we need to be very careful of this. If you are enlarging by a factor of 2, your area will be 2 squared of what it was before. If you are enlarging by a factor of 3, your area will be 3 squared of what it was before. So what we can say now, I know it isn't a square, but this used to be x and x. Rather, the area used to be x. So If the area of ABCD is x square units, determine the area of A dash B dash C dash, and that will be 4 times x units. And that is because every side is doubled, so therefore the area is 4 times as large. And I think that explanation should suffice. And guys, this is not only true for quadrilaterals, it is also true for a circle, let's say. If you have a circle with a radius of 1, and you now double that radius to 2, the area of the circle with the radius of 2 will be 4 times as big as the area of the circle with the radius of 1. Right, so a very, very important rule. That's one of the things that we always ask at the end of transformations, and you guys think, oh, I doubled, I enlarged by a factor of 2, so therefore the area must double as well. No, the area will then be 4 times as big. If you enlarge by a factor of 10, the area will be 100 times as big. So guys, remember to square it. Right. So that, I think, brings us almost to the end of our transformation questions, although it looks like we've got one more left. Now we are told that ABCD is rotated clockwise about the origin. And the first question asks us to state the general algebraic rule. So in other words, what are the 2 brackets? What happens to x and y if x and y are rotated clockwise around the origin? Well, 2 things happen. The y value turns into the x value. The x value turns into the y value, and it changes sign. Now, once again, guys, if you find it difficult to remember these rules, draw yourself a little Cartesian plane, put a point on there, and rotate it clockwise through 90 degrees. You will very soon be able to see whether your rule makes sense or not. Right, so stating the general algebraic rule, we've done that. xy turns into y negative x. And the next question then says, write down the coordinates of the images of A dash, B dash, C dash, and D dash. So what we need to do is we need to take our original coordinates and we need to apply the rules to each of them. So let's do it right on the screen here. Obviously, it's going to be in a different position. They don't ask us to draw it. I'm going to say A dash. What happens? X and Y turn around and the Y value gets the opposite sign. Again with B. X and Y turns around and the Y value gets the opposite sign. Obviously, they have different positions. I'm just writing them down. X and Y turn around and the Y value has the opposite sign. So that's -1, -2, and then 0 and -1 finally. My best tip that I can give you guys with transformations, guys, is draw a picture. Don't sit and try and learn the rules off by heart. If you're not sure what happens when you're reflecting or when you're rotating, draw yourself a picture and try and see, well, what happens if I move this point through 90 degrees? Very soon you will see whether you've remembered your rule correctly or not. Right, now the final part of today's revision lesson, also part of paper 1, of course, involves financial mathematics. So there's a couple of things that we need to remember when we are doing financial maths. Firstly, write down what is given to you and write down what is asked to you. Make sure that you select your correct formula from the information sheet. Guys, there's nothing worse than somebody selecting the wrong formula when they actually know what they're doing, or if you transcribe the formula incorrectly from the information sheet. That is just unforgivable. The next tip that I can give you guys is if there's a lot of things happening, if there are multiple transactions, draw a timeline. Always draw yourself a picture, some sort of a visual aid that makes it easier for you to know what's going on. Right, so let's just have a look quickly at the formulas that you should have dealt with by the end of grade 11. Firstly, For compound interest, and this is also used for inflation, we use this formula. For compound interest or for inflation. And remember, guys, that unless stated otherwise, inflation is always an annual thing. It only happens once a year. Then for simple interest, very similar looking formula, like so. This is for simple interest, and the simple interest formula is also, unless otherwise stated, used in the context of hire purchase. Right, so hire purchase is if you go and buy yourself a lounge suite and you're paying it off in equal monthly installments, that sort of thing. Right. Now, other things that we need to remember is if I say semi-annually or half-yearly or biannually or half-yearly, it means that my interest is compounded twice a year. So whatever my interest rate is, I need to divide it by 2, and whatever my n in years is, I need to multiply it by 2. So if it's 4 years, your interest is added 8 times in those 4 years because it's compounded semi-annually, so you just need to keep track of that. Then we've got quarterly. So if your interest is added quarterly, or, and we often catch you guys here, every 3 months. Quarterly or every 3 months, you take your interest and you divide it by 4. Now somehow whenever I say every 3 months, everybody is dividing by 3. But no, guys, you need to ask yourself, how many 3-month periods are there in a year? There's actually 4. And our years is then multiplied by 4. The others are pretty straightforward. Monthly would mean your interest is divided by 12 and your years is multiplied by 12. When we're dealing with weekly, we usually decide that a year has 52 weeks exactly, and when we are dealing with daily, we work on 365 days in a year. Now, the first 2 formulas that we spoke about are on your information sheet, and that's not actually a problem. However, there's another formula that helps you to convert from a nominal to an effective interest rate and vice versa, which is not on the information sheet. And this one you guys need to commit to memory. 1 plus the effective interest rate, I is for interest, is equal to 1 plus the nominal rate divided by m to the power m. Now those m's represent your compounding period. So if it is quarterly, it'll be 4. If it is monthly, it'll be 12. If it is daily, it'll be 365. Right. Now why do we need to have this formula in the first place? Well, when you are going to a bank perhaps to invest money, you have to be able to compare apples with apples. The one bank might say 10% interest compounded quarterly, and the other bank might say 11% interest compounded half yearly. Now, if we are not educated, we will be inclined to think that, oh, the higher interest rate must be better, I'm getting more money, but that's not necessarily the case. What we need to see is we need to figure out what does that amount to over the course of a year. And the best way to compare these things is by having a look at our effective interest rate, right? So if you want to compare 2 interest rates, different interest rates with different compounding periods to each other, the best method for comparison is convert both of those interest rates into effective interest rates and then decide which one looks like the best deal for you. Right, so that's just a bit of an overview of what we need to know in financial mathematics, but let's have a look at our first question. Question 5 on your worksheet says, Erin invests 140,000 Rand at 14% per annum compounded half yearly. Calculate the future value of his investment using the nominal rate. So what they're saying to us is, you now have to use the 14% compounded half yearly to calculate what his investment will be worth in 6 years' time. Right. So this is a compound interest calculation. So out comes our compound interest formula. A is equal to P 1 plus I to the power n. Now P, remember, stands for our principal amount or our initial amount. That is what the amount that we have at the start of the story. And at the start of this particular story, Erin had 140,000 Rand. So I'm going to substitute that in there. 140,000 Rand. Right, 1 plus the interest rate. Now guys, remember, the interest has to be written as a decimal. So 14% is actually 14 hundredths. So it is 0,14. And the question I ask myself is, how often is this 14% awarded? It is awarded to Erin half yearly. So this needs to be, the interest needs to be divided by 2. Then, the investment is in the bank or the building society for 6 years, and I always write the years there. And then I multiply the years with my compounding period. Now, guys, everybody knows that it's 12, but if you are feeling a little bit unsure, it's always a good idea just to check that that number and that number match up, and that number over there is actually in years, right? So this calculation is really relatively straightforward. I'm just going to substitute it into my calculator. I need to change the mode. Right, so I'm going to say 140,000 bracket 1 plus fraction 0. Let me just clear that, sorry. 140,000. Let's start from the top. Bracket 1 plus 0.14 divided by 2 to the power 2 times 6, which is 12, I know that. And Erin has actually made a pretty good investment here. His 140,000 Rand has more than doubled, which is great. Let that be a lesson for all of us, that we must save our money. And let's write down our answer. Very important in finance, guys, do not round off until the very, very end if it is a multiple step process. And then when you do round off to 2 decimal places, because that's what makes the most practical sense because we've got rands and cents. Okay, so very, very straightforward first question, simple application of our compound interest formula, and the only possible pitfalls is if you guys forget your compounding periods, which really at this point in your career you shouldn't. Right. Now the second part of the question deals with Erin again, and it says, Erin invests 140,000 Rand for 6 years at 14% per annum compounded half yearly. We know all of that. Now, convert the nominal rate of 14% per annum compounded half yearly to the equivalent effective rate. Now remember, guys, an effective interest rate is what is the interest in the end over a 1-year period. And as I said to you guys just now, this is the formula that you guys don't get. So please remember it. Okay. There are quite a couple of different versions of the formula available, but they all mean the same thing depending on which textbook you use. So 1 plus the effective interest rate is equal to 1 plus the nominal rate divided by m to the power m. The effective rate is what I'm looking for, so I'm going to substitute in here. My nominal rate is 14%. It's compounded half yearly. And guys, it doesn't matter how long the money is in the bank. That's besides the point here. So that m and that m must be exactly the same. So what I'm going to do, I'm going to calculate what 1 plus 0,14 over 2 to the power 2, everything is, and then I'm going to subtract the 1 on the other side. So let's do that quickly. So we've got a bracket, and 1 plus 0.14 divided by 2. Close the bracket to the power 2, and that is equal to, now keep that in your calculator, you don't have to write it down. The 1 on the other side is now subtracted, and the answer that I get is in a decimal. So I now need to realize that I need to multiply by 100, and guys, don't round off here. Or don't round off to 1 decimal place or anything like that. That could be disastrous. The answer is then 14,49%. So the effective interest rate is 14,49%. So what does this mean exactly? If they give you your interest twice a year, they've got to give you 7% and 7% each time, right? But in order for you to get exactly the same amount of money, if they're only compounding it once a year, they actually have to give you slightly more than 14%, 14,49%, right? Now the next question still deals with Aaron's investment, and it says, now use the annual effective rate to show that the same accumulated amount will be obtained then when you use the nominal rate. So what they're trying to prove to us in this question is we need to realize that whether you use the nominal rate with its compoundings or whether you use the effective rate, which is compounded just once a year, you will get the same answer. That is, of course, providing you didn't do any irresponsible rounding off at some point or another. So I'm now going to repeat my first calculation, just using the effective rate. So I'm going to say 140,000, 1 plus, now 0,1449, no compounding now at all, because that is a year, to the power 6. You will put this into your calculator and you will find that you get exactly the same answer as you did for the first bit, 315,306 and 82 cents. So a very nice question, this one, proving to you that nominal and effective interest rate, if used correctly, is the same thing or it amounts to the same thing. Also testing whether you can actually interconvert from a nominal rate to an effective rate. Right, let's have a look at our next finance question. Remember, guys, very important that you read it slowly and carefully so that you don't miss any information, and feel free to use your highlighter to underline anything that might be important. Right, so Judith deposits 80,000 Rand into a savings account. So that 80,000 Rand, I would presume, would be my P, my principal or my initial amount. The interest rate for the first 4 years is 8% per annum compounded monthly. So let's say 8% and monthly. That's very important. Thereafter, and this is what happens in real life, interest rates don't stay the same. The interest rate changes to 9% per annum compounded quarterly. Calculate the value of the investment at the end of the 10th year. Now, this might not be such a complicated calculation, but the moment some things start changing, I find it very useful to draw a timeline. It'll only take you a second, and use that to make sure that I'm keeping track of things properly. So let's have a look. And even though you don't specifically get marks for your timeline, in other words, you won't lose marks if you don't have one, it really does help the examiner also perhaps give you some bit marks here and there. Right. So I'm going to start at the, okay, so we've got 10-year periods, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So initially, into the account, I like to use an arrow to show that it's going in if I'm depositing money, and an arrow going outwards if I'm taking money out. 80,000 Rand goes into that account. Now, the interest rate for the first 4 years is 8% per annum monthly. So this is T0, T1, T2, T3, T4. So 1 year, 2 years, 3 years, 4 years. And for this period, my interest rate is 8%. And I'm just going to put monthly. Right. Then thereafter, the interest rate changes to 9% per annum compounded quarterly. So very important that for the remaining period of time, up to 10 years, so that's 5, 6, 7, 8. Have I got enough years here? Let's just see. No, I need another one. There's T10. So for the remaining 6 years, the interest rate is 9% quarterly. So the question asks me, how much money will there be in the account at the end of 10 years? Now, it's very important that when we're doing financial mathematics, that you don't round off until the end. Now, basically what we're going to be doing is we're going to calculate how much the money is worth after 4 years, and then we're going to take the amount after 4 years and we're going to grow it at the new interest rate up to 10 years. But don't round off in the interim. So let's have a look. I'm going to write my information into my formula. I'm going to say A, my end amount, is 80,000 Rand. Then 1 plus, and remember your interest rate as a decimal, 0,08. It's monthly, so divided by 12. And it is in for 4 years times 12. Then whatever my answer to this bit is, I am then, and you can do it in 2 steps and keep your answer in your calculator, but I'm just going to write it on the board in 1 step. Whatever my answer to this is, whatever the 80,000 Rand is worth after the 4 years, it now grows again. So this entire bit becomes my new principal amount. And now I'm growing it at 9% per annum quarterly. So that's going to be 1 plus 0,09 divided by 4. And that's then to the power 6 years, but 4 quarters in every year. So that would be how you would put out your question. If you find it intimidating having so many brackets at once on your calculator, don't worry. Do this portion, get the answer, and then say answer multiplied by that bracket. That's what I prefer, because sometimes we make a mistake somewhere along the line and then we have to re-enter so many things that it can actually be quite painful. Right, so let's enter this first bit into our calculator. So I'm going to say 80,000 bracket 1 plus 0,08 divided by 12, because it's compounded monthly, of course. Close the bracket, to the power 4 times 12, or 48 as you wish. So then we can already see what the money is worth after 4 years. It's already worth over 100,000 Rand, which is really nice. Now I'm going to grow it for the remainder of the time, and I'm going to say answer multiplied by, and I start a new bracket. 1 plus open the bracket, 0,09. Now it is compounded quarterly, so that's divided by 4. And it is in the bank for another 6 years, compounded quarterly. And my final amount is 187,725 Rand and 22 cents. Now guys, if you had done the calculation in 2 steps like I had, but you'd rounded off after the first step, it's not going to be 100% accurate. So please remember just to use the answer button on your calculator. So let's write down our final answer. So after 10 years, you can make quite a lot of money if you save, by the looks of things. 25 and 22 cents. Okay. So very important just to remember that you do have to take a break and carry on every time your interest rate changes. A common mistake that people make is they'll grow 80,000 Rand for 4 years and then grow 80,000 Rand for 6 years and add the two together. Guys, that's just not correct, because remember, by the time the interest rate changes, my investment is no longer worth 80,000 Rand. It's worth significantly more, and the interest has to be calculated on that bigger amount. Otherwise, you're not going to get as much money as you might have expected. Right, so let's have a look at our next question, and this one can be quite challenging because now we are working backwards. Julius wants to have saved 200,000 Rand in 8 years' time. So this is a man that's looking to the future. He wants 200,000 Rand in 8 years' time. Now, very important that in this calculation, the 200,000 Rand is not your initial amount. It is actually your end amount. Guys, remember to think of the financial maths as a little story. He's going to start saving now, and at the end of our story, in 8 years' time, he wants 200,000 Rand. So the 200,000 Rand is actually your end amount. And this is all happening over a period of 8 years. Okay. The question to us is, how much must he invest? So they're actually asking us to calculate P, the principal, or the initial amount. How much must he invest? Now, if the interest rate for the first 6 years is 6% per annum compounded monthly, so 6% per annum compounded monthly, and 8% per annum compounded quarterly for the remaining 2 years. Now, the first important thing I would think to do would just be to substitute into our formula. I'm going to say A is equal to P 1 plus I to the power n. Okay. But now, because the interest rate is changing, you can have 2 of these brackets, okay? But we'll deal with that just now. If the interest rate changes 3 times, we'll have 3 of those brackets broken up into the little bits of time. So it's going to be 200,000 as my end amount is equal to P. Now let's deal with the first part of the calculation. They say, let me just get my information here. The interest for the first 6 years is 6% compounded monthly. So we'll put that in. 1 plus 0,06 divided by 12. Compounded monthly, so that's 6 years multiplied by 12, which will be 72. Then the interest rate changes, and I'm just going to put another bracket for that. So then I say 1 plus, and the interest rate changed to 8% compounded, 8% per annum compounded quarterly, and that's for a further 2 years. So that is 0,08 divided by 4, because it's compounded quarterly, and that is for a further 2 years, so that is 2 times 8. Okay, guys, have a look at your information that you've put into your formula. Make sure you're happy with that. makes sense. 6% monthly, 6 years. 8% quarterly for 8 years. Sorry guys, it's not for 8 years, it's multiplied by 4. I was thinking of the answer, which is something that you guys often do, so it's actually 2 times 4. So it's for 2 years, compounded quarterly. See how important it is before you start punching things into your calculator, just to perhaps see, did I get everything quite right? Now, changing the subject of the equation, I'm going to say P is equal to 200,000 divided by these guys. Now, instead of dividing by those two brackets, what we can just do is use our laws of exponents and make those exponents negative. Have a look at what I mean. I'm going to say, why don't I just say 1 plus 0,06 divided by 12. 6 times 12 is 72, and make the exponent negative 72. Then you don't have to have such a big sum, and then the same thing here, 1 plus 0,08 over 4 and to the power negative 8. So essentially what I'm doing is I'm dividing by them, but instead of putting them at the bottom, I'm just making the exponents negative, and that amounts to exactly the same thing. Right, so now it's time to put all of this into our calculator and to see how much money must Julius initially invest in order to attain this investment target. So 200,000, right, bracket, and then we're going to have 1 plus 0,08 divided by 4, close bracket, to the power negative 8. I've just inverted the order, it doesn't matter, times by another bracket, 1 plus 0,06 divided by 12, and this is now all to the power negative 72. Okay. So he needs to invest almost 120,000 Rand, so 119,000 Rand and some change. Now guys, it's also very important when we're doing calculations that we look at whether our answer looks realistic. What if I now did this calculation and I found that he has to invest over 200,000 Rand? That doesn't make sense. Surely your money must grow when you put it into the bank. So it's very, very important that we keep on thinking of what makes sense to us in real life. Okay, so let's write down our answer. Final answer. And remember, again, we round off only at the very end, and when we round off to the nearest cent. Okay. Now, right, guys, that's all from us at Learn Extra. We hope that you guys have mastered functions, transformations, and financial maths. All the best for your studies.